Alright, so we saw what the critical section problem is. We saw that we need to ensure when multiple processes are working with the same data and are going to modify the same data, we need to ensure that at most one process is allowed to access its critical section at any given point of time. We saw there are three criterion which we need to satisfy: mutual exclusion, progress and bounded waiting. So if you are not quite familiar with these terms, I would recommend you to watch the relevant previous segments and then come over here. So that we saw is the critical section problem. Now what we wanted to be doing was come up with a system or a set of rules or some framework or mechanism that will help us enforce these constraints and hence solve the problem. So we're going to look at two solutions for the critical section problem. There are many. Right now we'll be looking at two. The first one is called Peterson solution. So the Peterson solution is an algorithm slash pseudocode slash logical framework which helps you to solve the critical section problem provided you have exactly two processes. This is an important point to note. If you have three or more processes modifying the same data item, the Peterson solution will not work. However, if you have exactly two processes, then the Peterson solution perfectly satisfies all three criterion. So we'll first see what this solution is, what is the logic, and then we'll see how it satisfies our expectations. So for the Peterson solution, the two processes need to share two data items: int turn, boolean flag of 2. So turn is an integer variable which will take the values 0 or 1 respectively. It will not take any other value. So we have two processes, as I told you, which are working with the same data item, and we want to ensure that there are no race conditions when these two are modifying the data, that is when these two are executing their critical section. So for that we're coming up with a framework. So let's call these processes P0 and P1. So we have this variable called turn which will take the values either 0 or 1, nothing else. So what does this variable represent? It tells us which process's turn it is to go into the critical section. So if turn equals 0, it means it is now P0's turn to work on its critical section. P1 cannot execute its critical section. Similarly, if turn equals 1, it is P1's time to execute its critical section and P0 needs to wait. So that is what this variable stands for. And we have boolean flag of 2, which is an array of size 2. You have two elements, both are boolean, and which means they'll take either true or false, and they represent whether that particular process is ready to enter its critical section or not. So flag of 0 being true means P0 is ready to enter the critical section, and flag of 0 being false means P0 is not yet ready. Similarly for flag of 1. So before we look at the solution, there are a few points I would like to clarify. Number 1, a process being ready to execute its critical section and a process being allowed to execute its critical section are two different things. So you will be allowed to execute your critical section only if you know that no other processes which work with the same data are currently executing. So if you know that mutual exclusion has been satisfied, then you will be allowed to execute your critical section. But being ready to execute your critical section simply means that you have all your prerequisites. If you need some input output to have been done beforehand, if you need some processing to have been done beforehand, all of that is done. It means you are ready. So that is the difference between being ready and being allowed to enter your critical section. That's one thing. Second, turn being an integer variable can either take 0 or 1 at a time. It cannot take both values. Meaning at any given time, either it is P0's turn to get into the critical section or P1's. On the other hand, flag, both the elements of the array can be true or both can be false. Meaning at the same time, multiple processes may be ready to enter their critical section, or at the same time, both of them may be not ready. So